Hi, hello, good afternoon. My name is Artur Kuliński and I'm cloud architect here in Google Cloud Poland. It's my first time on Confidence, so I'm the challenger and I'm pretending to be one of the Confidence legend speakers. I grew up from the development and I'm not seasoned security guy. But always the security was close to my heart, and development is almost half of my heart. So I think it's really important to connect these two words. I'm not going to say a lot why we should care about DevSecOps, because my colleagues did a great introduction, but I would like to quote Elisa May Austin, who really said, what is the state of the security in current development process? She says, and I agree, that we did enormous progress in the development. We introduced the agile methodologies. We introduced DevOps. My colleagues said that DevSecOps is just a hype word. And DevOps also was a few years ago. Everyone was talking about DevOps and no one really had idea what the DevOps really is. And now I think we are in a very different world. So we have a DevOps, we have agile methodologies, we really speed with the development, but security in reality doesn't keep up with this speed. And it would be very naive to think that the development will slow down just to match the security speed. What we really need to do is to speed up security in a secure way. So how? We should make the teams to work together. And it's really difficult because if you look into the field and we look into some statistics, it seems that we are really overnumbered by the developers. Depending on a source we look into, we see different numbers from 500 to 1 to 100 to 1. And this 100 to 1 is, I think, the most often found number. So if you want to do pair programming, we should have 2 hands against 200 hands to really support the development at current stage. Also, I think this is I would risk to say this is the most important sentences in the history of the software development. It's the Agile Manifesto. And let's try to look into this from the perspective of the security operations. I think it was also mentioned by my colleagues from PMI, where is this difference between the perception of the world, yes? How does it sound from the security people working software over comprehensive documentation? How do you feel when you hear responding to change over following the plan? I think it's a little bit scary thing if you think from the security point of view, but from the perspective of development, it's let's say, everyday situation. I have to, I should have start with agenda, but I will do it right now. I will have 2 parts in my presentation. First part will be a little bit wider and theoretical, let's say, about the DevOps. I think it will be quite complementary to what the practical side of my PMI colleagues showed you. The second part, I will dive a little bit deeper to show some tools and focus especially on protecting the software supply chain. So please, if you are only interested in the second part, don't give up during the first part. There will be also a console and cloud console in a minute. Okay, but going back to the DevSecOps, and there are really multiple aspects to address in this area. Education, also mentioned today. Culture and organization. The same thing like with the DevOps, yes? We had to change culture to close the gap between the development and operation. The same thing here. We have to introduce concept of secure by design, which is not that obvious to the people creating software nowadays. We have to take care about the technical aspects like pipeline security, runtime security, visibility. Take care about automation, which is also a source of really great risk nowadays. And also the tool to limit risk in many cases. We need to take care about the transparency of what happens in our environment, especially now when it's based on a containerized workload. So a lot of aspects, not going to address every of them because it would be boring and long, but I would choose 3 of them, which are, in my opinion, very important. First of all, organizational and cultural shift. First of all, we are outnumbered. We just cannot match with number of developers in number of security engineers. So what we really need to do, we need to inject like a dependency injection in a software development. We need to inject the security into the development teams. And in a field and in what I see in a practice, there are security champions being established within the DevOps team from internal the teams. But these are not guys that are forced to be the security champions. There are people like myself, the people that were really a little bit more sensitive around security than other parts of the team. It's quite obvious. If you think about DevSecOps, the sec is in the middle. So there will be always a way to bypass this middle part. We cannot, as a developers, we cannot bypass operations. It's not possible, but there is a possibility to bypass security. These are other ways. Use incidents to educate, not blame, especially in case of developers. You cannot make these champions to be the fully flagged security engineers within the weeks. So be realistic. Yes, you need to do it agile way. Iterate, improve, and give it time. We have a lot of great tools that promotes the communication and information sharing, which were introduced with agile methodologies, like information radiators, like stand-up meetings, and so on. Why not use the same tools for the security? Why not put the MITRE attacks posters close to the stand-up meeting place? Why not use the security as a great place for the great thing to discuss? Use the agile methodologies for the same sake as improving your software quality, because introducing security into the software development is improving software quality. Invest time in a champion. Invest time on your security team in champions. As my colleagues said, developers, the development team, they must understand. They must understand the reasons. So they stop perceive security standards and security requirements as, just blockers and things to slow development down. And they understand, we are developers are, okay, it's a risky, but we are reasonable people. We will follow things that we understand and see reasons for. And this is something that I haven't heard today. I believe that very key thing in a DevOps is introducing the development team into the risk management. But it was said, I think, in a DevOps handbooks. If you give developer one line of code to review, she or he will find 5 problems in this single line. But if you give 1,000 lines, they will say, it looks good to me. So the same thing with risk management. Use a lightweight methodologies like I've chosen here, Mozilla RA. Do it lightweight. So you have really valuable information from the process and not have a process that everyone will just try to complete as fast as possible. Very quickly, education. Also, problem that I think from the previous presentation on this topic is very obvious. It's sometimes really surprising when I am having a discussion, what is the, let's say, level of understanding of security. And it's not because people don't want to know about the security. I think there is some educational gap in this topic still. But first of all, responsibility. We discussed WAFs, firewalls. network perimeters. No, we need to understand that the security starts with the first line of developed code. It's not responsibility of some security guys to put a lot of magic devices to protect the software, which is really like a mesh or the Swiss cheese. So it's the first thing. If you have this understanding of responsibility and acceptance of this responsibility, then you can put sec in your DevOps process. And of course, the basic things like OWASP. Top 10, of course, but also we have things like juice shops, web goals, when developers can really quickly learn about the vulnerabilities and then understand how to avoid them. Container. We live in a containerized world. It's really amazing. From the perspective of developer, it's so handy. It's so nice that if you start using it, you're addicted. But the containers have the, let's say, load of the security consequences. Yes, and we are really important to make all the developers to understand what risks are in the containers. What are container escapes? What are risks in container images and images sources? What is privilege mode, capabilities? What you can do with some popular Docker switches? It's really eye-opening, and it will force the critical thinking about the software security. It's very important things. And the basic things, very often forgotten, like cryptography. Yes, I agree with my colleagues that we don't require every single developer to understand completely the cryptography, but we need them to understand how to use it. And the most important thing, in most cases, they should know that it's a bad idea to implement our own cryptographic libraries unless there is a really good reason for that. Kubernetes security, and also the things like cyber kill chain, Stride, MITRE, they are very useful things, very easy to understand and to start again, critically thinking about the security. Okay, that's a theoretical part. I just would want to put it out that, you know, it's time when it's not really hype work. It's something that we can really effectively start to implement into our development process. So let's now dive into protecting pipeline, software supply chain, our pipeline, delivery pipeline. Is it secure? Is it something which is internal and we should not care? Let's see. But first, a very short quiz just for you to answer just in your head. How much of software is written by our developers? So the answer is 25%, because 75% is in the open source, which we use as a libraries and dependencies for our software. 1 year ago, it was 20 to 80, so it's increasing. And just for curiosity, 85% of audit code, I put the source here, used components older than 3 years and having a lot of well-known vulnerabilities there. So yes, we need to care. You've seen the very similar image on a previous presentation, and that's true. In a pipeline, we have resources and processes which are exposing new attack surfaces. Yes, and if you think, I think it's quite common to have a knowledge about SolarWinds attack, and it was not, you know, attacking runtime. Yes, it was a code that was injected into source code, and it is very scary. I was analyzing this code, and I've got to admit, we used to do things like code reviews, but I saw the code, and if I was reviewing the code, even if it was my own code, it was so well fit into the style of this source base that it was probably I wouldn't spot it. So review is not enough. So let's look at it step by step with some example of tools and what we can really found in ourselves. Okay, so first of all, I don't want rectangle, I want arrow. So first of all, we start with code commit. But is this code written by our developers? Is it really code submitted, which is our code, legitimate code, or it comes from some other source? We have a pretty simple answer: sign it. And it's really not a problem. Of course, I'm not telling you that you should sign every code in every repository, but we are experts here from talking about risks, yes? So please evaluate the risk, and you have a systems like in case of SolarWinds. Maybe it's really worth to consider signing your commits or your pushes to the repository. And of course, to make it work, you must also from time to time validate the signatures, yes? So I'm not going to give an example here because the, for example, Git capabilities to sign in code are quite obvious. We really come to static code analysis, so using the SASTs, also mentioned today, SAST tools. They have a quite, let's say, mixed opinions, yes, because they are static. It means they can see problems and they cannot see that this problem is inside some control structure which really solves this problem, yes? And from people really experienced with SAST, I heard that it requires really a lot of effort to make it configured well, but still it's really worth doing. After static code analysis, we are in a source repository, or really it's that in a source repository. And now usually in the pipeline, the push to the repository triggers build in some environment. In our case, I showing here the Google Cloud Build as example because I'll be using it later. The build does a lot of things and it can do even more. One thing that I would like to focus on is the software composition analysis. As we saw a few minutes ago, our software really consists, in a majority, it consists of open source libraries. These libraries are taken from different places. They have a different maintenance level, and we really should check what we are using to build our software that we will put into production in a few moments. What we can find in these libraries, this is the moment when I switch to console. What you can see here, oh, maybe I use again. I have something called some project. This is the quite popular part of software taken from the GitHub repository. I deliberately changed its name to protect authors, and authors are close to my heart. This is the Java project, which is based on a Maven. So I downloaded dependencies from this project, yes. So they are in my local repo. As you can see, a lot of well-known things is used to compose this software. What I will do, I will use a very simple software, which is called Dependency Check, which is also one of the OWASP projects. It can be used in many different ways as an untask command line tool. It's not very fresh, and when I looked, the project is not very dynamically developed, but it does its own. It does the job it was created for. What I will do, I will just run this very simple check on this repository. I was going to show you the full process. This software is first downloading the databases of CVEs, analyzing and building the index of these CVEs, and then is doing analysis, but it takes time, and the time is really short for this presentation. So I decided to avoid that. Okay, so unfortunately it does some database maintenance, but it shouldn't take it more than a minute or so, and we will see. Okay, we are starting, but really to save our time. Okay, it does. It's analyzing. But I show you exactly the same, the result of the same analysis I did yesterday. I put it into our object storage just to make it clear. All the resources in the cloud you see during this presentation will be removed after this presentation. I know this is a very specific conference, so it will all be gone. So, just to make the statement, this is the result of the dependency check of this project, and it was not some really old project. It was a well-maintained living project. Yes, and what we see here, yes. From my perspective, I believe there is something. We should at least show this image to the developers, yes, to take some of our dependencies libraries and do this kind of check if we are not doing it right now, yes. We have even see some critical vulnerabilities present in these libraries, yes. So this is just as an example what can be done. There are really a lot of, I'm not going to endorse any special vendor here. I just use it as an example. We have things like Black Duck, for example, and a lot of other software that can do it, can be plugged into our pipeline and do this very important and overlooked step, which is composition analysis. Okay, so we are done with this, and our artifact lands in some registry. Yes, usually we have some freshly built Docker image, which is here. What we need to do now? This Docker image will be soon deployed to our environments, to some kind of runtime, usually to some testing, UAT, pre-production, production, so on. We should be sure that what we deploy to this environment is secure, is a right quality, and it went through all the process that we want it to go. And this is when we should do some kind of attestation. Probably the first attestation that we should do is to check for vulnerabilities in our image. And we can, this is another place when we can use multiple tools. If we use images, many companies at this point, especially with mature development process and security sensitive, they of course use internal registries of the base images, which is a very good practice. The images are hardened, they are clean, and then can be used. But in many cases, still open registries are used, and images are not well kept. Let's see how it looks for some images that we just take from the internet, from the repository. What I will do, let me take, oh, let's say we will take some popular software like Redis. Only, it's a random choice. I love Redis. This is great software. It's very widely used. We also use Redis in our cloud for the memory store. It's a great software. I just take the image, latest image. So I will move to artifact registry. If you use some, let's say, commercial product, usually you are in a very comfortable situation. Probably like in case of our artifact registry, you have some built-in vulnerability scanning capabilities. It's just turned off with a single click. I will create a repository for our case. It will be Docker in repository. I will use region which I use for the most of our demos because I have the most resources there. I can decide how to encrypt, but I will use it with the default Google managed encryption, and I will create repository. When I have repository, what I will do, I pull the Redis. So now what I need to do is to configure Docker to connect to our repository. I need to tag image to be pushed into the repository. And then what I can do, I can just push image to the repository. Okay. What happened when I pushed image to repository? It automatically triggered vulnerability scanning. And as you can see, there another time there is something to really care about. We should just try to make some score and decide what we really have to patch and what we can accept, yes? But it's really important to also make this exercise with developer if they are not aware what they download using the, let's say, random base images. Of course, we don't have to use the commercial product, or we can use any other tool, like for example, Trivi. I will use it this time in a container way, because we live in a container and cloud world, and we can do the same thing on using Trivi. Let's say we do it like that. And as we can find, Trivi is even less delicate for this image. I've got to admit, I was wondering why we have this difference from the number of found CVEs in these images. I had no time to really verify why we have 112 here and over 60 there, but I will leave it to you if you're really interested. But really, the images should be scanned. So what we did, we scanned the image, we deployed the image we fixed it, we patched it, and we are ready to deploy image to the environment. But it also, after passing the environment, it also should have some information that quality controls, automatic testing, manual testing, whatever actually happened, and someone is saying, yes, I certify this is it. So in our case, we use something called binary authorization, which is part of our service, but it's really based on two open source projects, Graphis and Kritis. Yes, Graphis is a database for the metadata for the images, when we can put the metadata about the attestation we do, and the Kritis is the Kritis give us possibility to verify those attestations. And I would like to show you how we can be sure that the container we put to our production the environment is really certified and is really attested that it went through the process we really wanted it to go, and also that no one on this pipeline is quite, let's say, complicated. The original image was simplified by myself, but can really be complicated in that many places here something really happened. But why not, if we get here, why not put our own images here? We should be sure that what we put here is a really legitimate image of the software we want to run. So I will move here to the GCP environment, and in the security part, we have something which is called binary authorization. And again, this is based on open source projects. We have this culture of sharing a lot of our ideas to the wide community. So the Graphis and Kritis are opened, yes. We have binary authorization. In our case, we have two attesters. One is called QA. I will start from this one. Vulns attester, that you can imagine, this is attestation of vulnerability scanning. So when I perform vulnerability scanning, and the score of this scanning, yes, so with each CVE criticality, there is a score assigned. If there is no CVEs with the score over 5, we assume that, okay, we can attest the image. there will be node attached to the image, which will be, of course, signed. We will use Cloud KMS. This is the advantage of using a cloud environment from my perspective, that all the infrastructure is there. Yes, I have a key management in place. I have a binary authorization in place. The Kubernetes is there. So I'm really don't have to, let's say, set up all it by myself. So I will use the KMS, the cloud KMS key to sign and then verify. Yes, the KMS is protected by IAM permissions. So only certain actors have the right to use the key, private key for the signing, and only certain actors can verify the signature using the corresponding public key. And another attestation is a Q&A attestation, which we can assume will be used when we pass some Q&A process, manual, automated. It's up to you, really. And then the next very important part is a policy. Yes, and in this case we have policy which says by default disallow all images. And then we have a Kubernetes cluster specific rules which defines that for the staging cluster we accept images with vulns attester, yes, attested to be scanned for vulnerabilities. And for the production clusters, we accept only images with these two attestations. How do we verify? Different question. Who is responsible to verify on a cluster that the attestation of the image are there? This is really the admission controller. The people playing with Kubernetes, they are definitely aware that the being called admission controller. The admission controller is used to allow or disallow pod creation, because it's on a level of the pod creation. If there is no attestation, the pod will not be created. So very quickly, let's see it in action. I will go to cloud build. First of all, I will quickly show you the build config. In the build config, we have a step which is called attestor. This step is using really, in this case, is using really a script which is using container scanning API to scan containers. If there is no CVE with score larger than 5, the attestation will be created. And there is another attestation here, or not attestation really. The process will stop and will wait for the image to get the attestation for the Q&A. We just emulate the manual processor giving the Q&A attestation here. It will even suggest us the command to do it. I did it before, of course. In a normal process, the submit will trigger this the build. I will just force rebuilding the image. In the meantime, we take a look here. We have two clusters. This is production cluster and staging cluster. If you look into the workloads, hopefully, yes, I cleaned it up. Hopefully, we have no deployments on any of these two clusters. So the build is going. We have container build. Okay. Waiting for another step, which is pushing container into the container registry. While it happens, I can move to some finished job and just explain it here. Yes, we have vulnerability scanning here. We have, when it's successful, we do the attestation. Then we create manifest, we deploy to the staging. When the deployment to the staging is done, we are waiting here in a build process. It's only sample process for this Q&A attestation. So let's go back to our build process and let's see if we have it done. Okay, so now we should be waiting on an attestation process. And if we go to the Kubernetes cluster, what we have here, hopefully, yes, we have the deployment done. What does it mean? We allowed container to be deployed here after we just did the attestation because of the vulnerability, because it's a staging cluster. Because I see the time is really running fast, what I will do now, I will try to skip the deployment to production cluster. I will try to deploy this image without the second attestation directly to the cluster. What I need in this case, let's make sure, yes, I will need a digest, and I will try to do it from here. I set up environment a little bit. Okay, I lost the digest, very clever from my side. Okay. My possibility to type and talk at the same time are limited, so I'm really sorry for this quiet time. Okay, we tried to deploy this container here. Let's see what happened. As you can see, it failed. You can see it was an attempt to deploy to production cluster, but it failed. It failed with the information that the admission webhook stopped it because there was denied by the attester. There was no attestation that the container passed Q&A. Yes? Okay, so we deployed here, and now we do all the things that we are pretty good at this point, I would say, in protecting the security of the cluster. Yes, we should look here for the things like container runtime security. Look for things like executing binary outside the image, like replacing libraries in running containers, and so on. Yes, of course, do all the protection from the front. And of course, the one thing that is missing from here, there is not anything can be really automated and replaced by the tools. Sometimes we need someone to just do some testing on our software. I'm inspired by the presentation by the Piotrek starting the conference. So yes, and the tools, yes. My colleagues from PMI, they avoided it, but we have a lot of tools to support the security of the pipeline. Software composition analysis tool, static analysis tool, dynamic analyzing tool, container analyzing tool. Of course, in a Google Cloud, of course, not only, we have a lot of tools that are, let's say, out of the box, which does a lot of this thing. And just a cloud migration. If we are in a cloud environment, and I hope most of you already are or will be soon, there is a thing that is very important. We really have a very strong security culture. We put a lot of effort to implement defense in depth and to protect any layer which you are using. Yes, then you can focus on this part which is left to you by the shared responsibility model. Yes. And you can really verify, you don't have to trust, you can verify that what we do in the layers below is really solid. My time is up. I was really prepared to talk twice as long to this. I was going to tell you about the visibility of what happens in the environment and the need to build the integrated logging pipeline. And I really advise to look into this direction. You don't have to start 2 years development project to build something, but you should use and iterate to start doing that, because it's really critical in the, let's say, distributed containerized world. I was going to tell you how to do it in a GCP, but fortunately we have the Security Foundation guide for the GCP, or just to get inspired, you can look into this document and you will find a lot of details how to do it with your logging infrastructure, how to do the detective controls on this logging. But I will jump to the wrap-up part. So what I would like you to take from this: introduce the SEC into DevOps and educate. It's not just a buzzword. We really need this, and we developers really want to know more about the security. Manage open source dependencies, because most of your systems are written not by your developers. Secure build process, because it will be focused by more and more attackers, and it's really complicated. There is a lot of surfaces when the attack can happen. Using open source standards or using commercial tools, restrict deployments to trusted images, the images that went through the process that you defined, and you want to be sure that it really went to this process. Run your workloads in trusted environments. And the thing that I really ran over, get visibility into your pipeline and your runtime in the consistent way. And it's very important to architect your logging so it can really be analyzed in context in, let's say, single place. Thank you very much. I'm done, and then let's return to the studio.